Okay. Graph the function by evaluating the points below. So you can see they're handwritten there on the left. When it says f of -3, for example, that means that x is -3.
Okay.
The thing inside parentheses is your x value. So we're going to make a table here with x and then y, and we'll just do this one at a time. We'll start with -3. To find the y value, you're putting -3 in to the equation up here, the top. And you really want to treat it like x is in parentheses. So when you evaluate this, it's -3 squared minus 4.
Okay.
Okay, so that is -3 squared. Well, that's 9 minus 4. Notice it's not 3 squared and then negated. It's literally -3 times -3.
Okay.
It's easy to make that mistake there. So this ends up equaling 5. Okay. So for the next one, -2, it's in parentheses, -2 squared minus 4. Will you attempt to calculate that for us, please?
Negative 2 squared
Yeah, -2 squared, -2 times -2.
times -4.
You're multiplying -2 times -2.
Yeah. -4.
What does that be? The previous one was +9, right?
+4.
Two negative, +4 minus 4. What does that become?
0.
All right. Got it. Okay. So now, next one here is -1. So you want to treat this as -1 squared minus 4. Will you calculate that for us, please?
Mm-hmm. -1 times 2 minus 4. Well, it would equal -2, right?
-1 times -1. That's
Yeah,
what that's
yeah,
one.
-1.
Positive one. Positive one. Positive.
Sorry.
2 negatives make a positive.
Mhm. Yeah, it equals
So what does that become?
-3.
Yes, not 0. Why did I do that? Okay. Now they get easier. They get easier because when you get to 0, what is 0 squared?
0.
0. And then when you subtract 4 from 0, what does that become?
Just 4.
You're subtracting, taking away.
0.
0 minus 4. You don't owe your bookie anything. Then you
-4
make a
then,
$4.
right?
Yeah,
-4.
yeah,
Yeah,
yeah.
sorry.
Okay. You went to the dentist, right? Not the not
Yeah.
a different doctor. All right. So now I want you to try the others here. I want you to try 1, 2, and 3. Okay, it should be much easier for you, and you should see a pattern in the answers. You should not see anything new when you're calculating those.
Okay.
And if you want to send them over each time, or give me the answers each time, that's fine as well.
Of what?
What you get when you evaluate each of these. I'm asking you to finish off this table.
Oh, okay.
1 squared minus 4, 2 squared minus 4, 3 squared minus 4.
One squared equals 1 minus 4 equals 3. So 1, 3.
Okay, very good. Except it's 1 squared minus 4, 1 minus 4. So it is in the ballpark of 3, but it's not exactly 3. There's a sign issue.
-3.
-3, good. And you've seen that value already.
Yeah. And then the next one would be 2 squared minus 4 would just be 0.
Yes. And how about 3 squared?
3 squared times 3 9 4 -5 or 5
You said everything right. You know, it is 9 minus 4,
5.
5. Yeah, and notice that it's the same as well.
Yeah.
Okay, now just to be clear, the first one we did f of minus 3, that was the first row. F of minus 2, f of minus 1, f of 0, f of 1, f of 2, f of 3. The answers you want to write next to it are the y values. The y values are what it equals. And
Yeah.
that if you go back up to that picture at the top where all those f's are written, you want to put like f of minus 3 equals 5, f of minus 2 equals 0, and so on. So let me know when you get all that down, and then we will graph it next.
Okay. Yeah, we can graph it next.
Okay. I'm just getting time here because I was in the wrong place to be able to grab it snip. Now I got it.
Okay.
All right, so they're ordered pairs. We're going to graph the minus 3, 5, the minus 2, 0, basically all these ordered pairs here. And that's going to give us some more information when we graph it. So I'm going to do that in red here. All right, so it's actually better to start at the vertex, but if you want, we can start up here. I generally think starting at the vertex is better. And then you had 1, -3, -1, -3, 2, 0, -2, 0, and then -3, 5, or 3 minus 5, something like that. Your graph should look something like this when you're all done. Put some arrows at the top. It asks you to label the points on your graph, so I guess you got to go in and label these. Seems like a lot of busy work, but we can do it.
Okay.
All right. Let me know
Yeah, that's
if you're good
fine.
on that. Okay. Now, some of the next questions we can answer both graphically and then through algebra. So you have to decide, which would you prefer? And let me step this first one in. You can kind of decide here. So it says, what are the coordinates of the x-intercept? So that means where it crosses or touches the x-axis.
Okay.
You can actually see that visually. If you've made a halfway decent graph, you can see that it crosses right there at those two places.
Okay.
So you give those ordered pairs. Okay, that's -2, 0, and 2, 0. That's using the graphical approach.
Okay, got it.
It's like if you have the graph, maybe you're at the orthodontist. Sorry, I keep saying dentist. But if you were to go to the dentist, they take X-rays. They have a picture to look at. There's also other ways to do it. The other way
Okay.
to do it here is to set x squared minus 4 equal to 0, and then to solve for x.
Okay.
Does that look at all familiar to you, how you might solve something like that?
Yeah, a little bit, yeah.
So this is actually difference of squares, or you can use the square root property. Do
Okay.
either of those sound better or worse than another?
Nah. No.
Okay, so here's difference of squares. X minus 2, x plus 2 equals 0. This is difference of squares factoring.
Okay.
Okay, this might be that oblique moment where you're like, oh, I forgot about that, or I didn't know I'd have to remember that. Yeah, you do. You got to remember all this stuff.
Okay.
So,
Okay.
so now you set each of them equal to 0.
Yeah.
Okay, and then you can solve each of those. Now, when you solve the one on the left, you're adding 2 to both sides.
Okay.
And then the one on the right, -2. And that's consistent with what we
Is
just
it like
found
the case
graphically.
1, case 2 again?
Kind of, yeah. Kind of,
Yeah.
yeah. Okay, so all we did here is show it 2 ways. We went to the graph and looked for them. We can also do it by hand, algebraically. They give the same answer.
Okay.
But because it's asking for coordinates, just make sure that you're actually giving the answer in coordinates. So you'd have to convert these to ordered pairs.
Got it.
All right, let's take a look at C. What are the coordinates of the y-intercept? So this is different than the previous problem. If you go back up and look at the previous problem, it says x-intercept. That's different than the y-intercept. And again,
Yeah.
we can do this graphically. We can literally go and look and see where does it cross the y-axis, the vertical one. So we go back up to our graph and look, where does it cross the vertical axis?
Uh, -4.
0, -4. Yeah, and it wants a coordinate again. So it's gotta be a coordinate. Okay. That's
Okay.
just looking at the graph. Now you can also do it algebraically. Algebraically means that x is 0. You're putting 0 in for x.
Okay.
So it's like finding f of 0. 0 squared minus 4. You did this earlier today. Can you tell me the result of that?
Of 0 squared -4.
Yes.
That would just be -4, right?
Yes. Okay. And that's consistent with our answer, right? Like it should give you the same answer no matter how you do it.
Yes, correct.
That would be frustrating if you did it 2 different ways and got 2 different results.
Yeah.
Okay. Again, it's got to be an ordered pair, 0, -4. Here you go. Here is the domain and range question. So until otherwise stated, the domain of functions that you know about are everything, all real numbers.
Yes.
Now they require you to put in this set builder notation. Okay, they don't, but you have to do it this way. So it's the curly brace, x, the vertical bar, x again, element of the real numbers.
Okay.
That means all real numbers. You have to somehow memorize that, remember that, not be surprised when they ask you to do that.
Okay. Got it.
All right. Now, from here, the range, well, there's a little bit more to do for the range. Do you remember the range calculation?
Uh, it's in some type of form, right?
Well, it's the same form, but how do you decide the range? Like, do you remember any words that go with the range?
I remember, but I don't at the same time. It's like,
So when you go out shooting,
yeah,
okay,
can you explain it again?
and
I'm sorry. We did this like so early.
that's okay. What I'm asking is like when you've been out shooting before and you
Yeah.
go to a target range, right? How are the
Mhm.
targets set up?
They're set up far away from you and
But they're not all far away. Some are shorter, some are longer, right? And you
right,
pick out
right.
a firearm that you're gonna practice,
Yeah.
and you'd say, oh, this one has a range of what? You might say it's from 50 to 200 meters or something like that. Or
Yes.
I'm good from 50 to 200 meters. So think of your range as like min to max,
Okay.
okay? Low to high, bottom to top.
Okay.
So if we go back to the graph, okay, see how it reaches a minimum here. This is the smallest value that it can take on.
Yes.
That's at -4. So the y values are everything bigger than -4.
Okay. Got it.
So you still have to give this preamble, this y such that y is an element of the real numbers, comma, y greater than or equal to -4.
Okay. Got it.
Have you ever looked at a book on firearms and their specifications, like their accuracy and things like that based on the type?
No.
They're incredible. It's a whole incredible world out there. I mean, it's too bad it's not taught, for people that enjoy that, because it's really interesting, just changing different things and you get different behaviors on the firearms. It's really interesting.
Huh.
Okay. On to number 2, more domain and range, right? Until otherwise specified, the domain is everything, all real numbers.
Yeah.
We'll talk about exceptions when we get there, but your default is okay, all real numbers. That's the X such that X is an element of the real numbers.
Yeah.
The range depends on whether it opens up or down. Okay, it's either if it opens up, y greater than or equal to some number.
Yeah.
And if it opens down, y less than or equal to some number. Does this one open up or down?
It opens up.
It opens up. So this is going to be one over here. In fact, it's greater than or equal to the smallest y value, which occurs at the vertex.
Yeah.
So you're looking for the y value of the vertex. What's the y value there?
0 and 1.
But just the y value. What's the y value here?
0, or I'm not sure.
X comes before y. X is the first number, y is the second number.
Yeah, I don't. I'm kind of confused on this.
Okay, just order, right? Like which comes before which? X comes before y, so it's the
Yeah,
first number is X,
comes
y is
before
the
Y.
second number.
Y is the second number, yes. The X
Yes.
comes before Y.
Like this is not a hard thing to remember. If you pick an order, you say, okay, I go X comes before y in the alphabet. I'm
Yeah,
not gonna be
X
confused with that.
comes before Y, yeah.
Yeah, that's a y. So the smallest y value this takes on is 1. So in
Okay.
your problem here, y has to be greater than or equal to 1 because it's the smallest y value, and it's everything that goes up from there.
Okay.
So you still have this y such that y is none of the real numbers, like that.
Okay.
Okay, let's do another one here because I feel like this is not clear at all. So let's
Yeah,
take a
it's
look here.
a little confusing.
So this has a vertex of a 3, 4. And this one over here has a vertex of -6, -3. For each of these, I want you to tell me about the range, okay? And I want you to think of it as this scenario up here. If it's up, if the parabola opens up, it's y greater than or equal to a number. If it's down, it's y less than or equal to a number. Basically, you have to decide, is this point up here at the top a max or a min?
Okay.
Is this a max or a min up here at the vertex?
Max.
It's a max. So all the y values are less than or equal to the y value here.
Yes.
Now, how about the one on the right?
It's not a max. It's a I forgot the name.
It's opening up.
Yeah. It's open up.
So y is greater than or equal to what number?
-6 and -3.
It's only one number. You have to choose.
-6.
It's the y. What's the y value here? It's not -6.
Oh, -3, sorry.
Yes. So you almost need to do this. You almost need to cross out the x value because it's
Well, how do you know when it's hell if it's the Y value you need to pick?
the range is always related to the y value. No
Okay.
exceptions.
Yeah, that's what I'm kind of confused on. Okay.
Okay. So again, whenever you, for the next 2 problems I give you, I want you to ignore the x value. Just ignore it. Be like, nope, don't care. Okay. So I want the range for both of these. Okay.
Okay, the left one, it opens up, up,
So is it a y less than or equal to or greater than or equal to?
greater than or equal to,
Okay. And greater than or equal to what number?
-2.
-2. Good. How about the one on the right?
Opens down, and
Okay.
it's less than. or not.
So less than or equal to what number?
6.
Good. Very good. What's the domain for each of these? If you just in words, what's the domain for each of them?
A parabola? What do you mean?
Domain. What did we
Like
say earlier about domain?
all real numbers.
All real numbers. Okay. Any questions on that?
No.
Okay, so let's just close out here with some more function notations since we don't have a ton of time here. Let's say I give you something like this, f of x equals x squared minus 3. Would you calculate for us f of -2?
Yes. F of -2 would equal, I'm not, what would I have to calculate?
You're putting -2 in for x, -2 in parentheses squared minus 3.
Oh, okay. That would make -4 subtracted by -3 is -1.
So what
Or,
is negative?
sorry,
-2 squared is 4. 4 minus 3 is
1.
1.
Yeah.
Okay, one more before we close out. Can you do f of -1, please?
Yes. -2 would be the final answer. Think, or 2, just 2.
-1 squared minus 3 is 1 minus 3, which is
Yeah.
-2. Perfect. All right. Okay, good job. We're going to go ahead and stop right there for today.